Okay, so picking up from where we've gone on, we've worked out our value of t bar, worked out our value of s squared, worked out our value of sigma squared hat. So we're going to say now then that t bar is normally distributed. We are accepting the mean from the null hypothesis. And then over here we need sigma squared hat over n. So sigma squared hat over n. That is the distribution of t bar. And now we've got that, we can pretty much proceed as we would with another question. And what we are trying to find now is our critical values. So, which critical value do people want to find first, the C1 or the C2?
C1.
Okay, C1. So if we're going to find C1, we want to find C1, so the probability x bar less than C1 is 2.5%, or as a decimal 0.025.
T bar x bar.
T bar, thank you. Thank you. T bar, thank you, Alex. So, phi of C1 minus our mean over that square rooted. I think you're all just doing this on your own now, which is great.
You're supposed to divide by 50. I times by 50.
Yeah, yeah, that's sigma squared over n at that point. So doing our trick here, antifying a small number, minus anti-5 will minus it. .96 is a figure that you'll come across, and that again will be ingrained into your brains fairly soon. Two-tail 5% test, it's always 1.96, and you can skip some of these, you'll just know that and can write that down. Then it's rearranging. If anybody's rearranging and can tell me what the C1 is.
21.388.
21.388 is what Chelsea said, that is what I have
well,
here.
Well, it goes on a little bit longer. But
okay. So, once you know what C1 is, we can find C2 as well. If I just go back a minute to the diagram, basically if you work out what that gap is there, the distance between those two, and add it onto the mean, we'll get C2. So C2 is equal to mu minus C1, that gap, added on to mu. And if you work that out, you will get C2 as well.
22.11.
Which is, yeah, 22.112. So I'm just going to redraw the diagram. So there's a diagram, similar to what we had last time. I've just put the critical values in it. Our sample statistic, T bar, which we worked out a long time ago, T bar was 22.14. 22.14 is there.
When did you work that out?
Okay. We worked that out from T bar was the 1107 divided by 50.
Okay.
We worked that out earlier on. If you look at the board, that's the calculation we had from earlier for T bar. So it's inner tail. So if it's inner tail, we will reject H0, which means we have no option but to accept H1, and then write a wordy conclusion. So we would say at the 5% significance level, we will accept H1, i.e. if we go back to what we said H1 was, that the mean has changed. The mean has changed, which means mu is no longer equal to 21.75 seconds. Now that might be a good thing, or it might be a bad thing. It depends whether a time increasing is a good thing in our study or a bad thing. But that's the conclusion that we've reached about our lab rats in a new environment.